conversation, please join me in welcoming to the stage the Research Fellow for the Stanford Steyer-Taylor Center on Energy Policy and Finance and the author of Cold Cash, Cool Climate, available at the registration desk and at a book signing at 4 p.m., Jonathan Koomey. John?
Joel, good to see you.
Yeah, have a seat. So you spent a lot of time looking at the role of technology in climate, but I think I'm going to start off with this, looking at the big problem here. Do you have a sense that, I'll say the public, but let's even talk about the professional public, professional world, really understands the magnitude of what needs to change in the climate?
I think people really grasp the level of change and the rate of change that will be needed. What we're talking about, in essence, is phasing out combustion in the next 30 to 40 years. We're talking about reducing emissions by more than 3% of year 2012 emissions on average over the next few decades. So very substantial changes, very rapid changes. And to do that, we need new tools to help us make those changes more rapidly than we ever could before.
And those tools, I know you've been looking at IT, and we talked about this yesterday at the beginning of this, how technology has the potential to be not a multiplier of problems, but actually the denominator, and actually some way to resolve and solve and ease some of these problems. Is that how you're seeing it?
Yeah, so I think that's a very important point. Information technology in particular is our ace in the hole for accelerating the rate of change and the possibilities for change. And I think it's important for people to know that in general their instincts about what's possible aren't usually right. People tend to underestimate the possibilities for change. And not just lay people, but also people in the academic community doing economic models embed rigidities in those models that don't actually exist in the real economy. So I think in general, people underestimate the possibilities for change in the medium to long term.
So when you look at the levers, how we do this, there's obviously the technology, which you already said is a key driver. There's the policy piece. There's the market in terms of how we get to change behavior. Are you saying that if we pull that technology lever really hard, that's the one that will make the changes so in a way that we don't have to ourselves change much?
Well, no, I think the level and rate of change that's required will mean changes in behavior and changes in the way we design our institutions. And it's important to know that these kind of changes have happened in the past. In World War II, the US auto industry was transformed from the auto industry to producing war material in about 6 months. And so that kind of change can happen when the urgency is there. But we need to have that level of urgency, and thus far we haven't seen that.
So let's get specific here. We've got this room full of people. We've got thousands more online. What's the one thing we need to do? What is the change, and how is technology, ICT, information technology, communications technology, how does it resolve that?
Well, so I think the most important thing to realize is that IT is our ace in the hole.
Right.
So I break it up into 3 big categories. There's improvements in our collection use of data. There's substitution of information services for material products and services. And then there's transformation of our organization. So on the first one, there's lots of great examples. There's a non-energy related one, but it's a nice one. The Proteus Biomedical folks have a 1 cubic millimeter sensor. Doesn't have a battery. It goes inside a pill that you take. It doesn't have a battery. It has an anode and a cathode. Your stomach juices are the electrolyte. When you take it, it sends a tiny signal to a patch on your skin that relays the information, I took the pill at this time. And that kind of detailed, tiny, low power information collection can transform the way we do medicine. It can transform the way we use energy.
So connect that to climate change.
Well, so these kind of data collection technologies can allow us to better match energy services demanded with those supplied. They can also allow us to do really powerful feedback. So there's a couple of companies that really couldn't exist without information technology. Makower, they designed a flying wing, carbon fiber flying wing that is tethered. And
it's a wind turbine on a kite.
It's a wind turbine on a kite, and they basically get rid of 80 or 90% of the material for a standard wind turbine. They operate at a higher altitude, so they can get much higher capacity factors than standard wind. And literally, that would not be possible without detailed data collection and then computer control of their device. Same for, sorry, go ahead.
No,
So Lit Motors is another example. They've created a two-wheeled gyroscopically stabilized electric vehicle that literally couldn't exist without the computer control.
So you're really talking about it connects those three things. So the Makani Kite and the Lit Motors. Danny Kim has been here on this stage, showing off this amazing machine, and the medical device. It's really data married to ever-shrinking sensors and technology. But it's the data piece really drives this. How much of this is hardware, software, data? What?
Well, I think that the most important thing is actually the data flows. So the technology is getting much better. It's getting much smaller, and as we're seeing the trends in efficiency of computing, they're able to operate at much lower power levels. So we can now put computing in places we never could before. But it's the collection of the data, and then there's an analysis piece. So developing tools that can help us analyze this flood of new data that we're going to be getting from sensors everywhere.
So if you're in business, how do we think about data, sensors, technology? Where should we be? Should we be looking in new parts of the business? Should we be thinking about it in ways that companies aren't? It seems computers are everywhere. It seems that data is flowing out of everything. How much more can we do, or how do we need to be thinking about it differently?
Okay, so another big area is the area of substitution, and this I think is very powerful for people operating in institutions. And by substitution, we mean substituting bits for atoms.
Right.
So downloading your music versus buying it on a CD, and we know that will save a vast amount of energy and reduce emissions.
Telepresence, not flying.
Telepresence, another terrific example. And those substitutions can have very powerful effects. I also like to talk about substituting smarts for parts. So in an electric vehicle, you don't need a standard transmission with all that gearing and all those parts to go wrong and cost something. You can actually use electronic controls with electric motors and just substitute that whole drivetrain.
So and then there's the 3D printing, which is really the future of manufacturing in some ways, some people say. Is that what's going to be happening? Is that all that it's cracked up to be?
Well, I think that it has the potential to really revitalize manufacturing in places you wouldn't think of. And you have Saul Griffith at Other Lab, who's doing some really innovative things now, creating custom designed bicycles that are much cheaper than what can be done by hand and custom. They scan you, right? They figure out your dimensions and then create devices that match what you need. And that, to me, that's the power of this whole area, is better matching of our abilities with the tasks we want to perform.
Where does this happen in companies? And I'm going to get to, what I'm trying to get to a little bit is the human resource needs, the jobs of the future. You're at Stanford, and I know you're not necessarily teaching. Are you teaching students? Sometimes. Okay.
Yeah.
So you're. I'm sure that there's this huge question, and not just from students, but from mid-career and others saying, where will these jobs be? What will they be? And where will they be? Where will I find them? And what do I need to know?
Well, so I think it does come back again to those data flows. Collecting the data, analyzing it, putting it to work to do feedback like Makani and Lit Motors do. The people who are able to design new software to do that analysis in real time will have an immense advantage. So there's a company called OSI Soft.
Right, Hayward, not far from here.
Yeah, so they're in Hayward, and they design industrial strength real-time data collection. And in virtually every major mission-critical facility in the world, they're there.
So does everybody need to go out and learn programming, or are there other parts on the design side, or the operations side, facilities, or human resource? Where?
Well, so it of course is a lot more than programming, because in order to design something that people will use, you need to have designers who are able to understand what people want and need, and ultimately the goal is to create devices and services that are so much better than what they replace that people are eager to scrap their old technology. And that's what we need to have the rate of change, to get to the emissions reductions that we need.
I'm still trying to get to this, this plastics question of, here's the one word you need to know, from the graduate. What's the modern equivalent of that in terms of how do you play in this space? Again, whether you're 22 or 52 and looking to find, be at the leading edge, not only of technology, but also of change and sustainability solutions?
I think that the main focus is on helping people to accomplish their goals and figuring out ways to use software, 3D printing, other new technologies to help them better accomplish their goals so they're eager to adopt a new technology and scrap what they've got. Because we're going to have to scrap. The rate of change we need is so rapid that we're going to have to scrap some of our existing infrastructure. There's no way around it. But we need to make people eager to do that by giving them products and services that are simply better than what they replace.
So what's the first, what's the biggest infrastructure we need to scrap?
Well, I think if you look at emissions, obviously it's basically a problem of oil and coal. Natural gas, of course, has emissions and there are issues there, but at the beginning you start with the most emissions intensive, and coal in the electricity sector, oil in the transport sector, those are the places where you need to focus.
And IT can do that?
Well, IT can help. Obviously, in the electricity sector, Makani is an example of a way to displace baseload coal generation. Mm-hmm. So capacity factors of 60, 65% can do that. You also need to start thinking about ways to transform institutions so that they can become much more efficient and drive efficiency through the organization. You'll hear from Dean Nelson in a little bit talking about how eBay did that. And the lessons that he has to teach, I think, are very pertinent to the overall story of reducing emissions.
So what Dean's going to talk about is about this dashboard they created, which is really about feedback loops. Yep. And having information readily available so that people who aren't necessarily experts can see in real time what's going on. What are the feedback loops that we could be creating within our companies or within our cities, for that matter, that would help us all get a better understanding of how much, if at all, we're moving the needle, or are we headed in the right direction?
Well, in the data center, the most important thing is to focus not on parts of the system, but on the end result, the task. And the task is computing. So if you focus on the cost of doing one compute cycle and figure out a way to drive that down, you will reduce energy use, you will reduce costs, you will improve the bottom line, both because costs are down and revenue is increased because you're using your equipment more intensively. So you boil it down to that one task that you're trying to accomplish. And once people have the information, which they never could have had before without this kind of information technology, monitoring and measurement, then they can start to drive efficiency. But without that measurement, you're at sea. You just don't know what to do. So having the measurement turns out to be critical to mobilizing the organization to change itself and transform itself and become better.
So IT gives us the information, it generates information, and ultimately has to be accessible to humans in a way that's actionable. Are you finding that that's happening? Because that seems to me to be a huge barrier.
Well, I think it's certainly happening. I think people are learning better how to present information in a way that's useful. I think there's one more thing about the institutional change story that I think is important. IT gives us economies of scale. So it allows us to experiment with organizational changes in a way that we couldn't do it before. So one example, CVS pharmacies, they develop innovations for their IT systems and they roll them out in a few stores. They test them, make sure it all works, and then it gets distributed to thousands of stores. Right. So in a way, it's like the computer designers who are then shipping out versions of their operating system that have been tested in beta testing. So that's an economy of scale that you, again, 50 years ago or 100 years ago, we don't have. We couldn't have had.
Rapidly prototype, rapidly iterate, and scale.
Right, and that turns out to be, again, it's part of IT being our ace in the hole. We can speed up how we operate, how we change our organizations, and how we change our behavior.
Good. A lot of that's in here?
It's in there.
Great. Go pick up a copy. Meet him at 4 o'clock to have it signed. Thank you, John Koomey.
Thank you very much.
Thank you.
Thanks.